Alrighty, we're back. Let me get my mic to the right place. Sorry. Not very well prepared. Well, anyway. Sudoku. Am I right? Holy. So, we are back on the rat run puzzles grind. Now, I do have to come clean about something. And partially it's my fault, but also not really. Rat Run 5. This puzzle, which I said last time I would try. Unfortunately, I have since then remembered what the trick was that I saw in Cracking the Cryptic to solve this. I wish I didn't. I wish I didn't remember that trick, but I kinda did. So, unless I re-forget it, this one's also going to be postponed until I don't know when. And as usual, Equilibrium, I already know the trick. Because of Cracking the Cryptic, this is the problem with watching those videos, huh? Is that I then can't do the puzzle myself. So instead, I'm going to try out multiple choice today. So it's a 3-star puzzle. I might not finish it, in which case this video will not exist. If you're listening to me at this exact moment in time, then that means I did finish it. Now, in how much time? Great question. We'll see. So, this I have not watched the video for. So this I'm going completely blind, as I should. So, Rat Run. Let's go. So, as usual, normal Sudoku rules apply. Gotta put digits 1 through 9 in each row, column, and 3x3 box. There's a very busy puzzle, so the 3x3 boxes are a little hard to see, but thankfully they're slightly delineated, so hopefully it won't be too much trouble. Then, Finks the rat must reach the cupcake by finding a path through the maze. The path must not visit any cells more than once, cross itself, or pass through any thick maze walls. As well as moving orthogonally, Finks may move diagonally if there's a 2x2 space in which to do so, but may never pass diagonally through a round wall spot on the corner of a cell. So, Finks is going to have to get to this cupcake. So, it could be as simple a path as that, for example. It will not be that, I can assure you, but it could be. Now, if Finks goes, let's say, here, then she may move diagonally like this, but what she can't do is something like that. So that is moving through a rounded corner. That's not allowed, as per the rules. Teleports. Entering a teleport will cause Finks to be instantly transported to the matching colored teleport. From there, she can continue her journey. Matching teleports all have identical digits, but teleports that don't match always have different digits. Interesting. Okay, so what that basically means is if Finks goes here, then the path is going to continue from here, for example. Whoops. In which case, it would actually be forced to go here, and then the path will continue from here, so, yeah. And the thing about matching... Jesus! I'm sorry, my mouse is very bad today. Just delete all that. The thing about matching digits, so these, no matter if Finks does or does not go through them, they have to contain the same digits. So if that was a 2, that would be a 2. But that being a 2 means none of the other teleporters, other than blue, could contain a 2. Which is pretty interesting, actually. So what I can instantly see is that that's going to mean that these are going to be a set of 6 different digits. So A, B, C, D, E, and F are going to be 6 different digits in total. Which is interesting. We'll see how that plays into the puzzle eventually. One-way doors. Finks may only pass directly through a purple arrow if moving the direction the arrow is pointing. An arrow always points to a smaller of the 2 values it sits between. So Finks could never do this, for example, because that's passing through a one-way door in the wrong way. And if that was a 6, that would have to be smaller than a 6. So it couldn't be a 7 or an 8 or 9. Test constraint. In this experiment, for any 2 adjacent digits along the correct path, one can be divided by the other to give an exact integer. i.e., one is a multiple of the other. Interesting. Okay. So, anywhere in the path, say the path starts like this, which it does, by the way, but anyway. If this was a 4, for example, then these two digits, let me see if I understand this. For any adjacent digits along the correct path, one can be divided by the other to give an exact integer. Okay. So this could be a 1, because these divided would give a 4. This could be a 2, because these divided would give a 2, 4 divided by 2. Or this could be an 8, because 8 divided by 4 would also give a 2. It couldn't be anything else. Yeah. So it's actually pretty constrained, in a way. But we'll see how that plays into it. And that's the rules. Yeah. So I guess let's get started. So that thing I was talking about, the path is definitely going to start like this, because Sphinx needs to move somewhere. And now we have a choice. We're going to go right or down. We're going to go down, because if we go right, we're going to end up at this intersection, and then we're stuck. Sphinx can't move there. So we're going to go down. And now I need to think about, can all 9 cells in any row, column, or box be part of the path in this puzzle? And what I'm thinking about is prime numbers. There's 2 prime numbers in the digits 1 through 9 that also don't have a multiple in the digits 1 through 9. Those are 5 and 7. And what I mean with that is that if there was a 5 here, for example, then what would this digit be? It could only be a 1. But then what would this digit be? Nothing. It can't be anything. Because there's no multiple of 5 that we can put here. We can't put 10 or 15 or 20. And there's nothing that divides 5, because 5 is prime. Now 3 is also prime, but that's okay, because there's multiples of 3 that exist in the digits 1 through 9. There's 6 and 9, for example. This would be fine. This would be completely valid right here. Mouse, please. Not the rat, not Sphinx. My mouse. Which means, can we do that? No, we can't. Because then 5 and 7 are going to have to be put into this box in some way. Now, 5 can't go in any of these, because it would have to be surrounded by 2 1s, but neither can 7, so those would have to be 5 and 7. But then, both of these would have to be 1 to match that, so that would be impossible. So that is not how we do things. We do go there, which actually is pretty powerful, because now we're going to come out of this teleporter, we're going to go over here, we can't go up, we're going to go left, can't go up, we're going to go down, and now we're here. Which, now I'm not sure what we're going to do in this box. We might spend a little time here. We might do a loop-de-loop. We might just leave. Jesus, what did I do? We might just leave. But either way, eventually we're going to leave. And then we're going to do something. I'm not sure exactly what yet. But now what I probably have to think about is, well, sure. We don't have to place all the digits here, but we do have to place 8 of them, and one of those is going to have to be 5 or 7. None of these can contain 5 or 7 still, so whatever that digit is that we're placing is in one of these 2 spots. If it's here, it's actually really powerful, because that means both these are a 1, and that would mean that is a 1. But the other digit that we're not placing goes over here. So that is a 5 or 7, definitely. Maybe, I'm trying to think of any other coloring I can do for this puzzle. That would make things a little easier to figure out. I don't think it's really going to be possible, though. Oh, well, here's something. This can't be the digit that we're thinking of, because if it is, it's 5 or 7, and then it must be surrounded by 1s. But 1 is definitely not bigger than 5 or 7. So instead, that's the other digit, and that is a 1 to accompany it. Cool. That's a start. So that's a 5-7 pair. There's our 1. And now this, unfortunately, could be anything, because 1 divides into any number. But now, okay, well, let me think of other digits that are difficult. 6 is kind of difficult. Because 6 can only be next to a 3. Or, well, actually, no, it can be next to a 3, a 2, or a 1. 6 is fine, actually. 9 is kind of difficult, because 9 can only be next to a 3 or a 1. Yeah. 3 can only be next to a 6 or a 9. Yeah, that's fine, actually. 4 can be next to a 2, a 1, or an 8. Okay. Weird. Well, one thing I can ask is, how are the digits going to be distributed in here? Do we have to put one of the hard digits, 5 or 7, into this line? Or, if we don't, then it means these are a 5-7 pair. But if they're a 5-7 pair, then what? I'm not sure. Well, this is sort of interesting. This is bigger than that. So that has to be not a divisor, but a multiple of this. Which I think means this is from 1, 2, 3, and 4. Yeah, definitely, actually. This is from 2, 3, and 4 now, because it can't be a 1, actually. Because if this was, say, a 6, then this would have to be smaller, because there's nothing larger that fits the constraint of this puzzle. It definitely can't be a 5 for the reasons we said later, and 7, 8, 9 don't work for the exact same reasons as well. So this is from 2, 3, and 4, and then this is a multiple of that. So it's either, well, it could be a lot of things. It could be 4, 6, 8. Actually, that's it. Or 9. Yeah. Yeah, no, that could be a lot of things. Well, maybe I'll still mark that, because, yeah, if that was a 2, then this could be a 4, 6, or an 8. If that was a 3, this could be a 6 or a 9. If that was a 4, that would be forced to be an 8. But, same thing, well, no, not same thing applies to this digit, because this could be smaller than that. So that could be a 1, or a 2. Well, it can't be a 1, but it could be a 2 as well. Never mind. That's not that useful. This has to be smaller than both of those digits. So, can't be too large. We can try to think about where each digit on the teleporters go, because as we know, they all have to be different. So for example, F. F can't go here, F can't go here because of that F. F can't go here because E can't be equal to F, so one of those two is F. Or purple, whatever we want to call it. D is going to go in one of those 4, it's not very useful. A is going to go in one of those 3, which is not super useful either. E, there's a lot of places it can go. B, in this box, is going to go on the left there. Not great. C in this box is sort of restrictive. It's at one of 3 spots. E in this box goes in one of 3 spots as well. Don't know. I'm just, okay. Fine so far. We've placed 1 digit, but we are fine so far. That's good to know. I'm imagining we're going to go into E at some point, and then we're going to have to choose from A, B, or C, because the puzzle is called multiple choice. So I'm guessing we're going to have to choose from one of those to go into. But I don't know, this area in the middle is very open. Like, it feels like things can traverse that in many different ways, especially this box, if we go into there. Like, if things got a teleporter through here, she could go, like that, even, and that's fine. Frick. So I'm sort of confused. Can I answer if things can ignore E and just go through here instead? I don't know. I don't know if I can answer that. if things goes right from this teleporter, she's either gonna have to go down and then loop like this, or up and then loop like this. If she goes left, then she goes straight. She can't do that because of those arrows. Can I prove which one of those is right? I don't know. I don't think I can. Seems like there's a lot of options for what can happen here, and that makes for a hard puzzle. This is 3 stars for a reason, I guess. Yeah, that's hard. 1 can't be there. So that can't be a 5 or a 7. Which means that can't be a 5 or 7. None of these can be 5 or 7. That can't be. That could be, actually. Actually, that could be as well. Because both of those could be 1, or both of these could be 1. I'm trying to think of this row. Sorry. I'm very lost. Oh. I'm stupid. The thing I was thinking about before. 9 can only go next to 3 and 1. So if I put 9 anywhere but here, then I'd have to have 2 1s in this box. That's a 9. That's a 3. That's not a 3. Yeah, okay, I'm correct in that. So this has to be a 6. Because it can't be 9. And it can't be a 1. So this is 6. Now this has to be a 2. Because it can't be a 1 or a 3. Okay, well, this is a lot of info that I should have gotten pretty early, but I didn't, because I'm kind of dumb. Now this has to be... Okay, so it can't be a 1, it could be a 2, or an 8, which means this is a 2 or an 8. It's not an 8, so it is a 2, and that's a 2. Great. Okay. Now, something interesting is that none of the other teleporters can be 2s. So none of those can have a 2. So 2 is actually pretty restricted in this box. Can't go up there. Can't go in here. Can't go there. So 2 is in one of those. 2 here. So one of those 4. Not great. Okay. Well, that's info. Because now this can be what? This can be a 1, a 4, a 6, or an 8. It's not a 4 or an 8. So this is a 1 or a 6. If this is a 6, then this must be a 3. Or a 1, actually. If it's a 1, that can be anything. That's super useful. Hmm. 1, 2. What digits are left in this row? Just think about this. 3, 5, 7, 8, and 9. That can't be a 3. That can't be a 9. That can't be an 8 either, because there's 2 arrows. It has to be bigger than. So that is from 3, 5, or 7. That's what I wanted to figure out in that row. That's from 3, 5, and 7. If it's 7, these are 8 and 9. 8 couldn't go there, so it would have to go here. That would have to be a 9. That is 2. So that I'm gonna color that blue. I'm gonna color these with their portal colors, just so I know what's going on. Unfortunately, blue is the only one that I know so far, but yeah. Yeah, I feel like we need to do some Sudoku, or like line test constraint logic, because I don't see how I can do anything with the path right now. Path seems pretty free to do like a number of things. A wide number of things. Well, we said that can't be a 5 or 7, but now that also can't be a 5 or 7. And by the logic we employed earlier... sorry, why couldn't that be a 5 or 7 again? Let me just remember that logic. Oh, because that would have to be a 1. Yeah, my bad. But now that's also not a 5 or 7. And by the logic from earlier, none of these are 5 or 7. Because they'd have to be surrounded by 2 1s, so these are 5 and 7. Which is good. It's pretty good. Pretty decent, I think. Something alright. These can now only be as high as 6. So they are 1, 3, 5, 4, or 5. Or 6. That's not a 6, it's not a 3. It's not a 1. That can't be a 5, I'm stupid. 5 is missing here. This is a 1 or 4. This is actually pretty restricted. Now where does 9 go? 9 must go next to a 3 and a 1. Actually, 9 could go there. Mm. 9 can't go there by Sudoku, my bad. So 9 doesn't go there, 9's... Wow, Jesus. 9 doesn't go there, 9 doesn't go in any of these. 9 isn't one of those. So that can't be a 3, because the 3 and the 1 are gonna have to be next to the 9. If that's a 9, that's a 1, that's a 3. If that's a 9, then that's a 1, that's a 3. So these are actually a 3-9 pair. And that's not a 3, so that is a 9. That's a 1, that's a 3, that's a 6, which works. This also works. This also works. And the last stitch here is an 8, which puts an 8 there. 8 is now designated as purple, which is good, since now 8 can't go in any of those. 8 can't go in that teleporter. So 8 is in one of those two. 8 is in one of these two. Okay. These both work for both of these, so that doesn't disambiguate which one these 5, which was the 7, but that's okay. Something else will eventually. These are from 1, 2, 3, 4, 5, 6, 7, and 8. That can't be 8, like I said. That's not very useful. Thought that was gonna be more useful. Well, that's sort of useful. That's from 4, 5, and 7. I'll keep that. Because that means this is from 4, 5, and 7. Which makes it which makes it hard for the path to go here. Because then this would have to be a 1 if that was a 5 or a 7, but it can't because of that. So this would be forced to be a 4 if the path goes that way. And then this would be forced to be a 4. Which is okay for now, but yeah. This has to be at least a 4. So this is from 4, 5, 6, 7, 9. That's not great. This has to be at least a 4. It's from 5, 7, 8, 9. That's a little better. 3 isn't there then. Okay. We're definitely gonna go into E, because otherwise this box being here wouldn't make any sense. But I don't know how to prove that at the moment. I feel like I've done most of the Sudoku that I can. What are these digits? 1, 2, 3, 4, 5, 7, and 9. 1 and 9 are definitely in there. Oh, 5, 7 paired there, because I mean, these are actually 3 digits. These are 1, 2, 3, and 6. I think. 2, 3, and 6, yeah? Yeah. Okay. So these are definitely 2, 3, 6 triple. Which, what does that do for me? These are still from 4, 5, 7, 8. These are from 1, 5, 7, 9. Yeah. Okay. Fortunately, that doesn't do anything right now. But remember that if... Oh, this is huge, actually. Okay. Remember that if the path goes this way, then this must be a 4. So then this must be a 4, but then the path must go here. Which means this can't be a 3 or a 6. It would be forced to be a 2. But now it has to go up or down. From a 2, it can't go to a 3. So wherever it goes, that's where the 6 would be. So if the path goes to A, that would be huge. That would give us a lot of info. And then from 6, actually, it can't go down to 2. So it would be forced to go to... This is huge. This is huge. The path doesn't go through A. Wow. Okay, that's really cool. That's really cool logic. Okay, that is a lot to think about, but I can prove that the path does not go through A. So, as we said, if the path goes through A, this can't be a 5 or a 7, because this would be forced to be a 1, and it can't by Sudoku. So this would be a 4. So keep in your minds, that's a 4. Now, if that's a 4, then the path comes out through here. Now, 4 doesn't go together with a 3, or a 6, so it would have to go with a 2. So now that is a 2. Now, wherever this path goes, let's say it goes up, it works in the same way if it goes down, but if it goes up, 2 doesn't go together with a 3, so that would have to be a 6. But now, what does 6 go together with? As we said, 1, 2, and 3. 2 has already been used, so now this is forced to go here, and this must be a 1 or a 3, but it can't be either, because 1 and 3 are already taken in this column. So I have proven that the path does not go through A, which means it doesn't do that. That is all blocked off. I can actually just block it like this. There we go. So if we go through E, which I still think we are going to, then we're going to be going through B or C, not A. Definitely. That is a lot of logic to prove that one thing. But that's pretty cool, honestly. That's actually really cool. Let me think about this. Interesting. Okay, this is cool. So this is an 8. The path definitely goes here, because Finks goes through that teleporter. Now Finks is either going to go here, or here. Wherever Finks goes, the next digit in the path must be a digit that goes with 8. Which digits go with 8? It doesn't have any multiples, so it would have to be a divisor. It's either 4, 2, or 1. But it can't be a 4 or a 1, because in that row, 4 and 1 are already taken. So one of these two is a 2. Wherever Finks goes, that digit's going to have to be a 2. And then there's actually a lot of freedom. Because if Finks goes here, for example, and then up, this could be either a 1, a 4, or a 6. And that's fine. And all those are completely fine. Oh, huge. Okay. Now, what if Finks goes here? What if that's the path? Now, what is this? It can't be a 1, a 4, a 6, or an 8. So, nothing. It doesn't exist. So, Finks doesn't go there. That's not our 2. Finks goes there. That is our 2. Which is blue. It's our blue digit. Which now puts 2 in there. And now, Finks is going to go either up or down. Don't know which. That's not a 2 anymore. Which puts our 2 in this box. Okay. Cool. Cool. Very cool. That's crazy. 2 has so much freedom. It can go to 1, 4, 6, or 8, and yet all those were taken in this row. That's really good puzzle design, I gotta say. Marty, you've outdone yourself again. I haven't even come close to finishing the puzzle, but you've outdone yourself. I'm 30 minutes in. This is gonna be a long one. Strap yourselves in, because mamma mia. Anyway, let's continue. So, well, wherever Finks goes, she's gonna have to cross through an arrow. And as we said, arrows in the path are kind of interesting. Because the digit on the smaller side of the arrow is gonna be forced to be 1, 2, 3, or 4. Now, whichever one of these it is, it can't be a 2. But if it's this one, it also can't be a 3, so it'd have to be a 1 or a 4. Well, it wouldn't be able to be a 4, actually, because then this has to be a multiple of 4, and the only one that exists is 8, and 8 is taken. So if we go down, if we go like this, then that is definitely a 1. Which would be kind of huge. But I can't prove that. This also can't be a 4, actually, because then that would put an 8 here, but the 8 has to be on top in this. That would put an 8 here, and there's already an 8 in the box, is what I should be saying. Sorry. So this would be forced to be 1 or 3. Now if it was a 3, that would have to be 6. Or 9. Both of those are fine. So if we go up, that is a 1 or a 3. If we go down, that's a 1. Definitely. Now what? Now this row is pretty restricted, actually. Yeah, this row is very restricted because guess what we haven't put in this row yet? 5 and 7. Now, can they go in there? No, because they would have to go together with 1s. And that can't be a 1, that can't be a 1, because that row. So these can't be 5 or 7. Those are 5 and 7. And now, I think that means... yeah. Finks can never traverse these squares. Which now traps us in this box, forcing us to go through E. Because if Finks does traverse these squares, then she's going to have to go, into that square and out of that square. And both of those squares, the one she's coming from and the one she's going to, are going to have to be 1. But whichever way you put it, both of the squares are going to be in this box. So they can't both be 1s at the same time. So these are acting like walls right now. Which means we can't go down, because that would trap us. We must go up, and then left, into the E teleporter. Let's go. Cool. Very, very good. Very good. Now. What? These are now given. They are 3 and 9. And that's fine, because 3 and 9 go together very well on the line, actually. If this was a 9, that would be a 3. That would be a 3 or a 1. Both of those are possible. Okay. There's a lot of options here. If this was the 3, that would be huge. Because as we said, if Finks goes up here, this would be a 1 or a 3. But if that's a 3, it would force it to be a 1. Which would then put a 1 in one of these squares for sure. Can I prove which one of these is which? If this was a 9, then wherever Finks comes from, she's going to have to come from a 1 or a 3. Well, something. Okay, if this is a 9, Finks goes up. Because if Finks went down, as we said, this would be forced to be a 1. Because it can't be a 2, a 3, or a 4, because that would put an 8 there. So this would be forced to be a 1. But now what is this? If that's a 9, then that has to be a 1 or a 3. But it can't be, because that would be a 1, that would be a 3. So if that's a 9, Finks goes up here. Finks does the up loop instead of down loop. But I can't be sure that that's the case. 3 goes well with 6, 9, and 1. Okay. Not sure. Well, either way, if this is a 9, then that's a 1 or a 3. If this is a 3, then that's a 1, a 6, or a 9. Either way, that can never be an 8. So that's not an 8. That is our 8, and it is purple. Which is good. This can't be a 2 or an 8 because of the teleporter rules. That they all have to be different, that rule. Again, I know I shouldn't be doing that. Whatever. This could be a lot of things because of the fact that that could be a 3. If that's a 9, this would be a 1-3 pair, actually. With that being a 3 and that being a 1. And that would put a 1 here, which would make it very easy to go anywhere. Which is probably exactly what's going to happen, in fact. But we'll see. 8. In this box. Can't go in there, or in there, or there. So 8 is in one of these 3. If that's an 8, then that has to be a 9. That's forced to be a 9. And then that's a 9. And then if the path goes there, that's a 3. I'm thinking too far ahead. Let's see. If that's a 7, then that is an 8 or a 9. Don't know. 8 in this box is pretty restricted. It can't go in any of those, and it can't go there. So 8 in that box is only 3 spots. Which is something. How about... no. Well, what can this be? Let me just make sure that I have all the options. Is a 1... It's not a 2. Is a 1, 3, 4, 6, or 9? It's not a 3 or a 9 because that has to be the same, and that can't be the case. So that's not a 3 or a 9. It's a 1, 4, or a 6. So if that's a 9, that's a 1, that's fine. If that's a 4, that would be forced to be a 1, because 3, 6, and 9 don't go well with 4. If that's a 6, well, problem is if that's a 1, that could go with anything. And if that's a 1, that could go with anything. So I can't really be sure what's happening there. Unfortunately. Must there be a 1 there? No. Because that could be a 3, 6, 9. That'll be fine. It's not, there doesn't have to be a 1 there. In fact, hold on. Let me go with this. If that's a 9, that's forced to be a 1. Now that's a 3. That's a 9. That would be forced to be a 3. Because as we said, if this is 9, it must go up. That'd be a 3. Okay, wait. I think this is a good line of logic. Let me think about this. If that's a 9, it doesn't go well with 6 or 4, so that would be forced to be a 1. Now that being a 9 puts a 3 here, 9 here. Putting a 9 there means we can't go down because of what we said earlier. Because both of these would have to be 1 at the same time. So it must go up. And now this is a 1 or a 3, but it's not a 1 anymore, so this is forced to be a 3. But now, what goes here? It has to be a 1 or a 3, but both those are taken. So that's impossible. And that whole line of logic started with with that being a 9. So that can't be a 9, which is huge, because 9 can't go there, or in any of those. So 9 is here. That's a 9, which means that's a 3. That being a 9 means this can't be a 6. It could still be a 1 or a 3. Which unfortunately doesn't put any pressure on there. But it does put a little pressure on these. Maybe? Ugh. Oh, well, that's a 3, which means now that thing that I said is right, and 1 is in one of these two. So 1 can't go next to the 3. So whatever goes next to the 3 will have to be a multiple. It would be a 6 or a 9. If we go down, that would be forced to be a 6. If it's a 9, that's actually fine, because the 9 would be naturally next to the 1 and 3. Should mark that that's a 1, 4, 6 now. Let's see, what am I missing? These are 1, 2, 3. Oh, sorry, 3 can't go down there or in any of those. 3 is forced to be there, which means that's not a 4, which means that's not a 4. That's not a 3 anymore, which means this can't be a 5, because 5 is not larger than any of those. So this is 7, 8, or 9. That's pretty restricted. 3 can still go together with 1 or 6. These are 1, 2, 6, and 4. That's not a 2. These are now from 1, 2, 3, 4, 9, and 7. That can't be a 9, because this arrow still has to be true, even if we don't go through it, and that can't be a 1 for the same reason. If we go up, this will be a 1. That can't be a 4 or a 7, so this will be forced to be a 9. One, 9, 6, 7. That's completely fine. No, it's not. No, it's not. Hold on. Yeah. Let me think about this again. Did I mark the wrong? I did. Sorry, not 7. Dumb. I'm stupid. 1, 4, 9, and 6. There we go. Sorry, my bad. Yeah. If we go up, that can't be a 9, so that will be forced to be the 9, which is fine, because it will be next to a 1, so that is a 1, so that is a 9 next to a 1 and a 3, which is what it wants to do. Dang it. Give me something here. I'm still very confused at what I'm going to do after I find which teleporter I need to go through. Because it still feels like I'm going to have way too much freedom whenever I get out. Because if I go through B, things can do like a bunch of weird shit. She could fucking do that, and how am I gonna be sure of what path she's gonna take? I don't know yet. We'll figure it out. But how? That is a great question. If that's a 1, that's a 4 or a 6. We'd go down. That would be a 1. Unknown. Let's see. Only 2 and 8 are taken as teleporter values. Can I think about what the other teleporters are? Not really. They're not really close to anything. It has to be bigger than that, actually. So that is a 6, 7, or 9. Oh, it's not a 9. It's a 6 or 7. That can only be a 6 if that's a 5. Oh, sorry. If this is 7, what is that? It's impossible. So that is forced to be a 5. Which doesn't really do much, but start. Confused. Interesting. If this is a 6. If this is a 6, it has a hard time going anywhere. It's not impossible, but it does have a hard time. Because if this is 6, again, 6s only go together with 1, 2, and 3. 2 is already taken, and we definitely don't go that way. So wherever it goes, if it goes here, it has to be forced to be a 1 or a 3. It can't be a 3, so it'd be forced to be a 1. If it goes here, it'd be forced to be a 1 or a 3. It can't be a 1, so it'd be forced to be a 3. So if this is 6, and it goes up, that's a 3. If this is 6 and it goes right, that's a 1. But I'm not sure this is... Oh, sorry, 1 isn't there. So this is a 6. My bad. Which makes that a 6. 6 is out of these. 6 is out of those. Okay. Pretty cool. Which now... What? Now what? Yeah, so if you didn't realize what that meant, 1 is definitely in this column in here, which also means that's not a 1, my bad. Which actually puts the 1 here. Because that row. So that could have never been a 1. That was always a 6. Now that being a 1 tells us nothing about that digit, but wait, it does tell us that we do go up. There we go. Because now we can't go down, because then what would this digit be? Nothing. So we do go up, which now means this is a 9, because it can't be a 4. And that's a 4. Cool. Cool. Now these are 1, 2, 3, 4, 5, 6, 7. Easy. That can't be a 7, because this would be smaller than it, so that is a 5. These aren't 5s. 6 is now our red digit. So 6 here is red, 6 here is red. What does that tell us? Not too much. Okay. Well, again, if Finks goes right, this must be a 1. If Finks goes up, this must be a 3. Now, if Finks goes up, this will be forced to be a 3, sure. But then what is this? This can't be a 1, so it'd be a multiple of 3. It can't be a 6, so this would be forced to be a 9. Very possible. Very possible, unfortunately. So we'll put a 9 there. It's completely fine. It's completely fine. Well, then the path will be kind of restricted. Because then Finks wouldn't be able to go here or here. Because again, 9 must go together with 1 and 3. And those would both be taken in that column. So Finks would be forced... Finks would be forced to go down, at which point that would be a 1 or a 3. But again, we're not sure if that's the case. I'm looking too far ahead into the future. I'm just saying. If Finks goes up, that will be what happens. Okay. What can I say about this? These are 5 digits here. These are 1, 2, 3, 4. 5, 6, 7, and 9. These aren't 2s. That's not a 4. So that's from... Oh, that's not a 4, because that 4 here. So these are from 3, 7, and 9, the orange teleporters. Again, the digits that are taken for teleporters are 2, 6, and 8 so far. So all their digits are fine. For now. So all the odd digits plus the 4. Those are all okay. Those are all free. So this is an odd or a 4. This is an odd or a 4. It's not a 1. I guess I can mark what that is then. This is 3, 5, 7, 9, or 4. It's not a 4 because that sees a 4. So that's definitely odd. It's from 3, 5, 7, or 9. This can't be a 1 because there's no digit smaller than 1. That's an 8. That's forced to be a 9. Putting a 9 here. Okay. Let me think about this. If Fix goes this way, what's going on with the numbers? Because then this can't be a 5 or a 7 because this will put a 1 there, and that's impossible. It can't be a 1, so that would be forced to be a 6, a 9, or a 3. So actually, it would be forced to be a 3 or a 9. So that would be a 3-9 pair, making both of those 7s, and that's impossible. Which, holy shit. Okay, hold on. Let me go through that logic again. This teleporter can't be 2, 4, or 2, 6, or 8. It also can't be a 4, because it sees a 4 there. One sec. Sorry, I had to take care of something important for a second. I'm back. Yeah, it also can't be a 4 because of that 4. So this is definitely 3, 5, 7, or 9. Now, if the path goes here, this can't be a 5 or a 7, because it would force that to be a 1. So this is a 3 or a 9. If it's a 3, 3s go together with 1, 6, and 9. Which 1 and 6 are both there, so this would be forced to be a 9. If it's a 9, 9s go together with 1 and 3. It can't be a 1, so that would be a 3. 3-9 pair forces both of those squares to be a 7, and that's impossible. So, through a very long-winded explanation, we have proven that the path does not go there. It goes up. Which is huge, because now that means this is a 3. And that's a 9. Which makes that a 9, which is huge. Those are not 3s and 9s. That's not a 9. Now, all the 9s are orange. Suddenly. And now, we only have 2 teleporters left. This is not a 3 anymore, because that. This is a 5 or a 7, which means this can only be as big as 6. It can't be a 2, a 3, or a 6. So it's a 1, a 4, or a 5. It's not a 5, actually, because of that 5. So it's a 1 or a 4, which means it's definitely not an 8. Which means 8 isn't one of those 2. Don't know which. Not quite. Not quite yet. Okay, but big progress, big progress. Now, we definitely go out of the 9. And again, 9 can only go together with 1 and 3. So it can't go there, it can't go there, it must go down. And that is a 1 or a 3. Now, if that's a 3, then what happens? We must go either down again. Okay, let me think about this. if that's a 3, it can't go left in any way, because none of these digits go well with the 3. So it would be forced to go down, making that a 1 or a 6. I guess that's possible. Yeah. So I can't quite disprove that that's a 3, but it has a hard time being a 3. Either way, we still have a lot of freedom of where to go, which kind of worries me a little. Or a lottle, honestly. Okay. Let's move our attention to... what? I'm starting to think about how is Sphinx gonna end up at the cupcake. There's a few ways. Well, there's exactly 8 ways that Sphinx could ever end up at the cupcake, and that's from the 8 adjacent squares to it. Now, these are all out of the question because Sphinx never traverses those. That is out of the question because Sphinx never goes to that teleporter. Is this in the question? I guess. Because Sphinx could end up at that square for sure. Or Sphinx is gonna go up to it. The frick does that mean? Actually, that's not quite out of the question, because Sphinx could go something... Whoops. Could go something like... Could go something like this. That would be fine. So Sphinx comes from one of 3 directions. Either right, down, or down left. And actually, that's even not out of the question yet, because Sphinx could do something like this. So Sphinx could also come through there. Okay, so it's not a great question. It's interesting to think about, but it's not quite what we need to do. So instead... Oh, one second. Okay. Sorry about that. Yeah, I feel a bit stuck. We've made a lot of progress. Like, that's good. I'm not gonna say that we're full stuck, but like, oh, 1. Sorry. Where does 1 go in this box? Can't go there, 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 there. 1 goes here. Which now means 8 isn't one of those 2, which means that's not an 8, which puts an 8 there. Which puts a 4 here, which means that's not an 8. That's now a 3, actually. So that thing we said is true, and it does go down. And that's now a 1 or a 6. It's not a 1, so it's a 6. Whoops. 6. And that's a 7. And that's a 6. And that's not a 4. And that's a 5. Whoops. Making that a 4 or a 7 now. That's not a 3. That's not a 6. That is a 7. Which makes that a 5, 7, 5, 6, 4. Putting a 4 on that teleporter. 4's not here. That did a lot. Holy shit. Okay. Wow. We might be able to get the... Yeah, we can get the digit on the cupcake, which is really huge. 1, 2, 3, 4, 5, 6. Ooh, it's a 7, which is huge, actually, because, again, 5s and 7s can only be together with 1. So wherever the cupcake comes, the rat comes from, is going to have to come from a 1. Which, none of these are 1s, which means one of those is where it comes from, so one of those is a 1. I don't want to mark that because it's between boxes, but we got to remember that. It must come from a 1. These are 1 and 3. These are 7 and 8. That's not a 7. That's an 8. 7. These are... I feel like, yeah, we're very close to being done, actually. That did so much work. Holy crap, that one move did, like, the entire puzzle. I mean, the path still has a lot to build. But, okay. Okay, I feel like we're done for now with Sudoku. Actually, just a little more. These are... Whoops. Ah! That's a 4. Keep that. These are, 1, 2, 3, 4, 5, and, 8. So, 8, 5, 1, 8, 5. Good lord. And then these are 1, 2, 3, 4, 5, 6, 7, and 9. That's a 7. Making those not 7s. That's not a 7. And now we can do what I was trying to do, like, a while ago, before all the Sudoku happened. That can't be a 2. Because where does this go? It either goes here or here. But wherever it goes, it can't go together with a 4 or 7. Because, again, 6 can only go together with 1, 2, and 3. So one of those is going to have to be a 2, which means that's not a 2, which means that is a 4. And now... now what? Good question. Well, again, the path is either going to go here or here. If it goes here, that's a 2, so 2 can't go together with a 5. 2 would have to be forced with the 8, which is fine. If it goes here, 2 can't go with a 7 or 5, so it would be forced to go to the 8 or the 4, which would be fine, because then the 4 would be forced to go to the 1, and then the 1 would go here or here. So there's a few options still. But these are from 2, 3, and 6. That's not a 3 or a 6, so that's a 2. That's from 3 and 6 now. That's not a 2. That's not a 2, which puts a 2 here. Which means these are from 1, 3, and 8, I believe. Yeah. Puts an 8 there. We're extremely close to finishing the Sudoku. But there's still a lot of path left. I broke something. I didn't. How did I... Wait. Oh my god. I didn't even think of this. Holy crap, that is genius. Oh my god. The final move of the puzzle. And it's genius. There's one more digit that 7 can go with. 7. 7 is a multiple of 7. It's 7 times 1. There are no 1s around the 7 of the cupcake. It comes from here. It comes from a 7 to a 7. That's insane. That is nuts. Because guess what? That's going to help us build the path. Because now, where does the 7 come from? 7 can only go together with a 7 or a 1. So it definitely doesn't come from there or there. It's going to come from here, which means that's a 1. Which means that's a 9. The path comes through here. This is now a 1 or 3. Because that's how 9s work in this puzzle. So that's a 1-3 pair, making that a 4, that a 1, and that a 6, and that a 3, 2, 6. Putting a 7 there and a 2 there, so now the path does go here. That is given, it's a 2, no, not 2, Jesus. Can't see right. That's a 9. Okay, we're very close. We're very close. Okay. Oh, a few more things actually. Holy crap. We're so close to being done. This is a 7. And that is just not a 1. A 4. And now, ladies and gentlemen, we have just 2 1-3 pairs left. That is all that's left in the Sudoku. And that's going to be resolved by connecting these 2 parts of the path, somehow. Now, how are we going to do that? Let's think of this. Okay, here's one thing. This can't go down. This can't go down like that. Because then, where does it go? It doesn't go up, because 8 and 5 can't connect. It doesn't go here, because 8 and 7 can't connect. So it goes there. But now we're stuck, because 4 and 5 can't go together, 4 and 7 can't go together. So it doesn't go there, it goes here, which now forces it to go here. which now means we're at a 1, which makes things a little hard. Let's see. Well, one thing we can't do is go down, because then this 5 must go together with a 5 or a 1. I've learned my lesson, but it can't, because there's none left here. So we either go down left, or just left. If we go down left, then where do we go? Nowhere, because the 7 can't go up, here, or here. So we do go here to the 2. The 2 now can't go up, because remember, we still need to connect to this part of the path, and now how the heck are we going to do that? We're not. Because we're going to have to go down somehow, and we can't go down from the 8, and we can't go down from the 4. So it doesn't go up, it doesn't go to the 5 or the 7, so it goes to the 8. Now this 8 can't go to the 5, the 7, or the 9, so it must go down, which means that's a 1. That's a 3. The path connects like this, and 3, 1. Holy crap, that was incredible. I love that. I love that puzzle. Wow, that was really fun. That was really, really fun. That was really good. Wow. How the heck? That last trick at the end with the 7 going together with another 7, that really caught me off guard. That was really, really good. I love that one. That was amazing. Holy crap. Experiment completed successfully. Cells visited 42, one-way doors used 2, teleporters used 4. Although initially startled by the noise of the teleports, Finks quickly became adept at using them. Heart rate returned to normal by the time the cupcake was reached. Teleport B overheated after use. Further calibration required. And it took just over an hour. Not bad. Yeah. Wow, that's crazy that it has a unique solution. Wow, Marty, what the heck? Well, anyway, there you go. That's another rat run done, which... Not counting the 2 that I unfortunately kind of already know the tricks for. I don't know the solution for, because... I don't know about you, but I can't memorize 81 digits in a specific order. So I don't know their solutions, but I know the tricks that you would use to get to them. So not counting those, we have 2 left. Discontinuous and censored. What I might do is maybe do both of these in a single video. Because again, I kind of already know the trick, so they're not going to be as fun, and they might not take as long. So I might do both of those in one video just to get them out of the way, and then we can start working on these 2. Yeah. We'll see. We'll see what we do. For now, digits on the path in row 6 from left to right. So those are 9, 3, 1, 6. 9, 3, 1, 6. Bah! There we go. Cool. That was wonderful. That was a wonderful puzzle. So many cool tricks throughout the entire thing. I don't know why there's next there. My bad. So many cool tricks throughout the entire thing. I kind of gave up on the coloring halfway through, but I guess we can finish it just to see how it looks. 9s were orange. 8s were purple. 2s were blue. I don't know why it's not getting all of them. My bad. 6s were red. Is that all of them? 4s were yellow. Yeah, that should be all. Well, 9s were orange. And there's one missing here. 9s were orange. And 9s were orange. Okay. Well, okay. Again, the coloring wasn't strictly necessary, but it did help at times just to figure out where things could go. Yeah, that was really fun. That was awesome. I thoroughly enjoyed that. These rat run puzzles are so cool, man. They're so cool. I did notice, by the way, that this has phase 1, so there's gonna be more in the future, which I'm super excited for. I don't know when they're gonna come out, but that's okay. We'll see. But yeah, super fun. Love these. Love these a lot. We'll see what we do next. For now, though, that's it. Good night.